Hello, I'm Miss Shahana, and I will be talking about linearization.
Where do we use linearization and how do we find function of equation of linearization? We will look at those cases. Now let's move. Okay, how can we approximate these values? Square root of 3 and cube of 2.01. We don't know square root of 3, and square root of 3 doesn't even get whole value. So it is approximately 1 point something. And cube of 2.01 either doesn't get whole value. It is approximately 8 point something. But how do we find some part of this something? Okay, here we need linearization. But what is linearization? Assume that we have a function y equals x squared, and we want to draw tangent line at point 1. So here it is already written, this tangent line is 2x minus 1. If we zoom, we will see that around 1, both functions get the same value. And if we zoom, we will definitely see that both functions coincide. So from x from 0.997 till 1.003, both functions get the same value. So we can find the value of functions where around 1 by this function or either this function. We can use both functions because they will get the same value. And this is actually linearization. As definition, if f is differentiable at x equals a, then the approximating function L of x equals f of a plus f prime a times x minus a is the linearization of f at a. And the approximation says that f of x approximately equals L of x. So around 1, these functions approximately equal to each other. F of x approximately equal L of x represents that statement. And here, L is the standard linear approximation of f at a. And the point A is the center of the approximation. Since we have found this tangent line function around 1, this 1, a equals 1 here. Therefore, this a is called center of the approximation. And this linearization function looks like the tangent line function, which was y of x equals y x0 plus y prime x0 times x minus x0. So linearization is the same function with tangent line because it is also a tangent line at point A. Okay, let's look at this case. It says that find the linearization of f of x equals square root of 1 plus x at x equals 0. First, we need our function. So what do we have? We have f of x, which is square root of 1 plus x. Next, we need our a. Here, a will be 0. Why? Because it says that we need to find linearization at x equals 0. So we need to find linearization. We need to draw a tangent line at point 0. Therefore, our a will be 0. Next, we need to find derivative of the function. So since we know that, we can write this function as 1 plus x power 1 over 2. And its derivative will be, this power will come in front of the expression, and it will be 1 over 2 times 1 plus x power 1 over 2 minus 1. So this is our derivative. And next we need to find f of a. So a is 0. When we substitute 0 in the function, we will get square root of 1, which is 1. And f prime a is 0. We need to substitute the 0 in the prime function, and we will get 1 over 2. Next, we need to write all the all the values in our function equation. So f of a, which is f of 0, is 1. plus f prime a, which is f prime 0, 1 over 2 times x minus 0. So our equation, we have found that 1 plus x over 2. And it says that f of x approximately equal L of x. So our f of x was square root of 1 plus x, written here, approximately equals this L of x, 1 plus x over 2. Next, approximate square root of 3. So we have written this question in the beginning. Now we will analyze. How can we approximate? We can approximate this value by the use of linearization. The equation was like this. So what do we need? First, we need to find our function. Function could be f of x equals square root of x. Why? Because when x is 3, we will get f of 3 equal square root of 3. So, and we are asked to find square root of 3, and we will find square root of 3 by this function. Okay, we have our function, but how can we choose a? It says that we can take a as a number, which is the closest number that we know its square root of. So what's the closest number that we know square root of? It is 4. Therefore, we will take a equals 4. Next, we need to find f of a, which will be square root of a, which will be f of 4 equals 2. Next, we need to find derivative of the function. So we know that we can write square root of x as x square root of x equals x power 1 over 2, and its derivative will be, this power will come in front of the expression, and it will be 1 over 2 times x power 1 over 2 minus 1. And this is, since in the power we will get negative, we know the property of powers that if we have negative power in the numerator, it can be written in the denominator without negative sign. So f prime x equals 1 over 2 times square root of x, and f prime a is 1 over 2 square root of a. When we substitute a, we will get 1 over 4. Next, we have to substitute all the values that we know. F of 4 is 2, f prime 4 is 1 over 4, and a is 4. We have written, so our function is x over 4 plus 1. But we need to find L of 3. We substitute, we get 1.75. Then the approximate value of square root of 3 is 1.73205. So we are approximately correct. Our whole parts are the same, our tens are the same, but hundreds are not the same. So we are approximately close our number. And in the graph, if you look at, this is our function f of x equals square root of x, and this is our line, which is L of x 1 plus x over 4. And we can see that around 4, both functions get the same value, and when they go far from 4, and their values get, the difference between the values get bigger. So 3 was the close, 4 was the closest one to 3, therefore we took 4 as a. Next, analyze this. We need to approximate 2.01 cube. So we have our function, our equation. First, we need to find the function. Function could be f of x could be equal x cubed. And why? Because when we take x equal 2.01 and plug into the function, we will get 2.01 cubed. And next, we need to find a. We take a as a number which is the closest to number that we can calculate its cube. So what's the number that we know its cube? And it's close to 2.01. It is 2. And therefore, we take a equals 2. Next, we find f of a, which will be f of a equals a cubed, and f of 2 equals 2 cubed, which is equal to 8. Next, f prime x, and we need to find the derivative of the function. F prime x is equal to 3x squared, because from the property of derivative, we know that the power comes in front of the expression, and the expression will be 3 times x power 3 minus 1, which is 3 times x squared. And f prime a is 3a squared. When we substitute a in the function, f prime 2 will be 12. So when we write in the equation, we will get f of 2 plus f prime 2 times x minus 2. We wrote all a's in the we wrote 2 in the place of a's. And we know that f of 2 is equal to 8. We write f prime 2 is equal to 12. And we open the bracket, we will get 12x minus 16. And we need to find 2.01. Therefore, we substitute x 2.01 in the L function. We will get 8.12. What's the correct value of 2.01 cube? It is 8.120601. So we are approximately correct. So this whole parts are the same. Tens part also same. Hundreds part is also same. And next part we are not same. So and we are approximately correct. We just want to approximate the original value. And if you look at the graph, here we will see this is our x cube function, and this line is our y equal L of x equals 12x minus 16 function. And we can see that around both functions approximately get the same value. So therefore 2.01 approximately close to the cube of that function. That was it.
So that was me, Shahana, who was explaining the topic. I hope that helped.